internal regulators. And we talked about external regulators, cyclins versus growth factors. Whew. And then the question was, what happens when we lose control of mitosis? And the answer is this disorder, this disease, that's really kind of fundamentally different from just about every other disease we know. It's different because you know about infectious diseases, right? More than you ever wanted to at this point. That they are transmitted by germs, that they're transmitted by pathogens, microorganisms like bacteria or viruses that actually pass from person to person and then infect a person and cause harm. And you probably also know a little bit about genetic disorders, which don't get passed that way. They get passed in a different way. How do you get a genetic disorder typically? Where does that come from normally? Your parents. They pass down the wrong DNA, I guess. They pass down DNA to you that gives you a problem, right? Cancer is that weird kind of in-between disease. Cancer is a genetic disorder. It is a problem with your DNA. But typically a genetic disorder affects every cell in your body because you got your first cell from your parents that had their DNA in it, and every cell you got after that, your whole body is from that original cell. Cancer's not like that. Cancer actually starts somewhere in your body and isn't affecting every cell in your body. Cancer, it only takes one cell, which is real weird for a genetic disorder. It only takes one cell to have that screwed up bit of DNA. Well, here's why. We kind of mentioned how some of that cyclin checkpoint type stuff is there to make sure a defective cell doesn't reproduce. Well, what happens when that goes wrong? What happens is a cell with the wrong genetic tweak, with the wrong bit of DNA in it, forgets to stop dividing. That cell just keeps dividing. Why is that a big deal? Well, okay, let's say it's a cell in the skin of my arm. Suddenly I have a cell, an arm skin cell, that doesn't know how to stop dividing. Well, thing one is, every time it divides, it's going to copy that mistake. And so now it's not just one cell that doesn't know how to stop dividing, it's two cells that don't know how to stop dividing. And you know how fast that can get out of control. Remember the bacteria thing? It's exponential growth, right? Pretty soon they become millions of cells that can't stop dividing. Okay, but big deal. First of all, okay, it happened and I have a lump of useless arm skin cells on my arm. What do we call that? That's called a tumor. Good. So, what's so scary about a tumor? Does it sound scary? I don't care about arm skin cells. Go to the doctor, cut them off. I don't love needles, but numb me up and cut it off, I'm good. Well, let's go even simpler than that. My body is super good at fighting things off. I get sick every year and then I get better. What's the problem with cancer? What's the problem with a tumor? Why can't my immune system get in there and kick butt?
It's like an actual cell. So you can't treat it like another disease with other pathogens. So it's like your own cell.
Ooh, it's your own cells. What does it have that are going to make your immune system useless, Amanda?
Markers.
Not DNA markers exactly. They are genetic. But what do we call those? What do they call them? This is back. So much of this comes back to chapter 7. Marker proteins. Yeah, they are coded for by DNA. And your cells and your cancer cells have exactly the right marker proteins so that your immune system goes and finds them and goes, yep, nope, that's good. That's us. Don't kill it. That's a problem. Very much flying under your immune system's radar. You can imagine that there's all kinds of research going into trying to change that, trying to find ways to flag cancer cells so that your immune system does go after them. They've had some success in that. Still haven't gotten the big, huge problem though, which is, okay, I've got a lump of arm cells, cut it off. Well, it grows back. Maybe you didn't get all of it. Who cares? It's a lump of arm cells. It's not going to hurt me. What is the deeper problem? What could happen if this is the wrong kind of lump of arm cells? And the words we use for that, if you haven't heard them, you can have a lump of cells that isn't a problem, and they can analyze and discover that it is, and they'll use the word benign, right? A benign tumor versus a malignant tumor. So what is it that a malignant tumor can do that's a little scarier than just a lump of arm cells? Nithya, how can it spread? Anybody know what that process looks like? I mean, does it just creep up my arm and start to grow onto, like, keep cutting it off, it's fine. How would it get, like, okay, and a really important, you're right, there are organs where I have a lot less room to tolerate a lump of useless cells than my arm. My arm's not a problem. My brain, that's a problem. But how would this lump of arm cells ever get any cells into my brain? It seems impossible. Amanda? The transport system for your entire body, right? The way to do that, if you're strategizing and you're the cancer cells, the successful way to get to any organ in the body would be your bloodstream. And it turns out malignant tumors have that ability. They are able to grow and sort of push apart tissue until they break that wall between the tissues and the bloodstream. And they can actually start to break off cells into the bloodstream. Some of them even cause new blood vessels to grow close to them so that they can accomplish that. But at the simplest level, basically, the process is called metastasis. They metastasize. And to kind of oversimplify, what they're doing is breaking off cells into the bloodstream. And then those cells kind of hitch a ride and can land anywhere. And that's when things get scary with cancer. And, you know, there's the common places for cancer to start are not the scary places, right? The common places for them to start are the places where we see the most mitosis. There's no coincidence that skin cancer is the most common kind of cancer. That's because skin cells are constantly dividing, one, and two, they are constantly exposed to UV light, right? Which is a mutagen, meaning something that can cause DNA mutations. UV light is mutating your DNA all the time. UV light is causing damage to your skin. I don't know if you saw my screensaver, right? It's causing damage to your skin all the time, and you're losing cells. You're experiencing cell death because of UV light all the time. It's really uncommon for your DNA to get tweaked in that one way that causes a cell to become cancerous. But of course, it only takes once. So the more you're exposed to sunlight, the more likely it becomes. They start in places where there's lots of cell division. That's also why lung cancer is. Your lung cells on the interior, they're in contact with the outside world. They have to be dividing and replacing themselves all the time. Nithya, you had a question? They just don't have that mechanism where they bust into the bloodstream. Yeah, they kind of just stay on the surface. Good question. So the scary places that those once harmless cells can land tend to be the organs that have the least room for being pried apart. They tend to be organs that are the most multi-purpose. The liver and the pancreas are really kind of workhorses for the body that do a bunch of different jobs. So there's not a lot of wasted space in them. So as soon as things start getting moved aside and pressured by masses of useless cells, we start having problems. The brain, of course, is the whole control center of the body, so obviously that's a problem. So that is very much a quick, superficial overview of cancer. You're going to learn more today with an activity you're doing. Real quick, though, just as far as some of the things we know, there's a gene called P53 that we know is part of the regulatory mechanism of mitosis. Mainly we know that because after endless analysis of the genes of cancer cells, P53 is the gene we find defective in them the most often. It is sometimes called the tumor suppressor gene. Because of course, every genetic defect is a is in a gene that normally does something useful, and the useful thing this gene apparently does is keep bad cells from reproducing.